Hello and welcome to the first distance learning lesson held by myself. So, bear with me because it might be a little bit rocky, but here we go. We're starting a new topic, that is physics. Yeah, that's the right response there. As always, we have our title. So, the first topic we're looking at is speed, velocity, and acceleration. And a key question that we're going to answer is, what is the difference between speed and velocity? So once again, writing down 1 to 3 on a bit of paper or on a Word document, because we're going to just quickly review some knowledge we've covered before. Our keywords are scalar, vector, velocity, acceleration, deceleration, and so that's what we're going to look at. Okay, so first question. Okay, bit of biology revision. Which of these would you not find in an animal cell? Is it a nucleus, a mitochondria, a cell wall, or a cell membrane? Okay, have a little think about that one. Lovely. All right, next one. What is the unit of energy? So is it joules, ohms, watts, or coulombs? So this is a unit of energy in biology, in chemistry, and in physics. So bond energies are measured in joules, or joules per mole, and also the amount of energy you get out of a process like respiration would be measured in joules also. Lovely. What is the charge on a proton? So some chemistry. Is it positive, negative, neutral, or is it all of those? Okay. What is the charge on a proton? Is it positive, negative, neutral, or all of those? Okay. So here's our answer. So cell walls are not found in animal cells. Joules is the name of a unit for energy. I always like to make up. It's named after the Frenchman Henri Joule, but that's a lie. And protons have a positive 1 charge. Okay, so if you got all of them right, lovely. All right, so moving on. So once again, we're looking at speed, velocity, and acceleration. A little quote from Top Gun there. I feel the need for speed. Okay, lovely. Right, so as mentioned previously, this is a new unit. This is Physics 2 or P2, and it's made up of a couple of different subunits. So you've got P2.1 motion, so movement, how stuff moves, how objects move through space and the atmosphere around us. You got P2.2, which are Newton's laws. There's 3 of them, and you will see them in action all around you on a daily basis, which leads nicely to the last one, which is forces in action. Okay, so this is a unit we will be covering, and excellent. So let's move on to what our objectives are going to be. So we want to start off with a bit of terminology. What's a vector? What's a scalar? We're going to, in this lesson, we're going to look at speed, velocity, acceleration. So there's going to be some equations, very famous equations that we need to memorize. Okay, so difference between scalars and vectors. So say you have a car like this car here. Obviously it can move forwards, it can move backwards, it can change speed, it can change velocity. Right, so scalars are just numbers while vectors have a direction too, and the best way to get your head around this is to give some examples. So speed is a scalar. If this car was to go, if we were talking about the speed and the car went in this direction, that's forward, we'd say it had 30 miles an hour if it travels at that speed. It could also go in this direction, i.e. reverse, and a lot of cars can reverse about with speed if you put your foot all the way down. So that 30 miles an hour, you see we can't tell the difference. It's just 30 miles an hour. We don't know if it's forwards or backwards. Alright. So when we say a car's speed is 30 miles an hour, we're not specifying the direction. So other scalar values are stuff like distance, okay, mass, and time. Okay. So vectors are quantities but with a direction. So when we say a car has a velocity of 30 miles an hour, it means it's going forwards, whereas minus 30 miles an hour would be backwards. Okay, so other examples of vectors include displacement, which is the vector for distance, forces are always vectors because they always act in a certain direction, and acceleration. So acceleration, you can once again have positive acceleration, increasing in velocity, and you can have negative acceleration, decreasing in velocity. All right. So that's definition of vectors and scalars. And on the quiz that I have, myself and Greg have put on the OneDrive. Sorry, not the OneDrive, on the Google Classroom, you will be asked that question just to check you understand the difference. Remember, as it's a video, you can pause and go back, re-listen to what I've said, have a look at the slides, and I recommend you do so. Okay, so now we're going to move on to the speed equation. I know we've been talking about vectors and scalars. It could also be called the velocity equation if we change one or two variables. So now I'm going to look at this speed equation, a very famous equation. Okay, so the classic speed, distance, and time equation, we've got speed is equal to distance divided by time. Okay, so if you cover up the speed, you'll notice it's the distance divided by the time. So that's what speed is. It's how far you've travelled, the distance, and how long it's taken you. Okay, so if it takes you less time, or if you travel a greater distance in the same time, your speed will increase. Okay, so say it takes 1 second and you travel 10 meters, your speed is going to be 10. And if it takes 1 second again, but you travel 100 meters, your speed is going to be 100 meters per second. Okay. So you can rearrange this. Say you want to find the distance that you've travelled. Okay, so distance, if you put cover up this the top of the triangle, you'll have distance equal to speed times time. Okay, distance equal to speed times time. Okay. Yeah, so they often make it trickier by in your exam questions asking you to convert between units. The classics are kilometers to meters, and kilo means 1,000. So if you got 1 kilometer, that is 1 times 1,000 or 1,000 meters. Right, so that's in terms of distance. And we've got the time one here. So milliseconds to seconds. Milli, like a millennium, is 1,000 years. Okay, be careful because it does look like it would be a million. No, it's a millennium or a milli, so it's 1,000th of a second. Okay, so it's 1,000 milliseconds in a second. Okay, so moving on to some examples of using that equation. Okay, oh, hello. We've got a washed and blow-dried cow. Look at it, beautiful fur there. The farmer has taken a lot of care over that cow. What a handsome cow. Okay, oh right, got distracted. So we've got this cow and it walks 20 meters, okay, in 50 seconds. So we need to find its speed. Okay, so I'm going to use my equation. Right, I want to find speed. If I go back to speed, speed equals distance divided by time. Okay. So speed equals distance divided by time, the distance being 20 meters in this case, and the time being 50 seconds. So what we need to do, where we see distance, we're going to write 20, and where we see time, we're going to write 50. Okay, oh, there's our triangle to remind us. So speed equals distance divided by time. We'll move on with that. So you'll notice where it's distance, we put in 20, where there's time, 50. So the speed of the cow is 0.4 meters per second. Not very quick. Wouldn't want to mess up its lovely fur there. Alright, so as said previously, say this is the maximum speed of a cow, say it's speed is 0.4 meters per second. How long would it take to walk 32 meters? So this is asking us for the time. So time in seconds is equal to the distance divided by the speed. So we've got the distance being 32 meters and the speed being 0.4 meters per second from that previous question. Okay, we plug that into our calculator. If we plug that in, we should end up with 40 seconds, which sounds about right. So if it, okay, yeah, sounds about right there. Moving on. So here are some further questions. I recommend you pause the video now and work your way through them, because in 5 seconds time I'm going to show you the answers to those questions. So once again, if you pause the video, 5 seconds time I'm going to show you the answers. So that's 5, 4, 3, 2, 1. Here we go. So there are the answers. So take your time to have a look at them, check that you've got them right. If you haven't got them right, then once again feel free to drop me a message on Google Classroom and I can talk you through where you've gone wrong. Because I've got this as a little sound effect next to me, I'm going to use it again. So if you got 3 out of 5 and above, this is for you. If you got less than 3, this is for you. Okay, seems to work pretty well. Really, it doesn't matter how many you got, as long as we work out where we've gone right or where we've gone wrong, and then we improve on it. Okay, so that's the speed equation. Let's describe and use the speed equation. Speed equals distance divided by time, and you end up using it so much it just sticks in your brain. Or come up with a little rhyme. It sort of rhymes as speed equals distance divided by time. There we go. It's one for you. That was embarrassing. Moving on. So next thing, we've got this concept we call acceleration. So we're going to look at acceleration, what it is, and we're going to use the acceleration equation and do some calculations. So basically, acceleration is a measure of the change in velocity. Okay, so acceleration is the change in velocity divided by time. So the units for acceleration are meters per second squared, because it's meters per second per second. Say that again, so meters per second per second. It's a bit of maths, laws of indices or laws of powers. That's how you get to those units, but don't worry too much about them, you just need to memorize them really. Okay, so we're going to expand on this equation, and also we have some symbols for this equation. So the symbols, symbol for acceleration is A. Change in velocity is the symbol for change is D, which is really shorthand for a Greek letter delta. Don't worry about that. It means a change in. And V is velocity and time is T. Okay, so change in velocity really is final velocity minus initial velocity equals change in velocity. Yes, it does. So often we need to calculate the change in velocity to work out the acceleration. Okay. Positive acceleration is where you speed up. Okay. Negative acceleration is where you slow down, but you could still be moving in a positive direction at that point. Okay. So the symbols for final velocity are V, for initial velocity they're U, and as I said before, change in velocity can be dV, but right change in velocity. Okay. So here's some examples of questions. So there is a cyclist, and let's say as she approaches the finish line, she's in a tight race, she's leading the pack, but someone's chasing from behind, and she increases her speed from 11 meters per second to 15 meters per second in those final 25 seconds. So a bit of competition. So all we need to do is we need to recall that equation. Okay, so acceleration is the change in velocity divided by time. So acceleration, change in velocity divided by time, v minus u divided by time. So her final velocity would be 15, her initial velocity would be 11, and the time would be 25. So 15 minus 11 divided by 25. So that gives you 4 divided by 25, which is 0.16 meters per second squared. Okay. So same cyclist for this second question. When the cyclist crosses the finish line, she immediately applies the brakes and comes to a stop after 3 seconds. Calculate her acceleration as she crosses the finish line. So she's won the race after a burst of acceleration previously, and she wants to slow down and get a drink. Okay, so once again, same equation. Acceleration is final velocity minus initial velocity divided by time, obviously in seconds. Final velocity this time is a stop, so stop would be 0 meters per second, minus our initial velocity, which from a previous question is 15 meters per second, and dividing it by our 3 seconds. If we plug those numbers in, we get minus 15 divided by 3, which gives us minus 5 meters per second squared. So she's slowing down by 5 meters per second every second. So it'll take her 3 seconds, as it says in the question. Okay, so it's negative because she is slowing down. Okay, so for those of us who are aiming for sort of a level 6, at this point it's the right time to finish. So thank you very much for listening. I hope that was useful. Once again, any questions, let me know. Send me a message on SD Connect or email or Google Classrooms, whatever is most appropriate for you. Okay, for those that are going for those higher grades, sort of 6 and above, we need to stay on and listen to the next section. Okay, so for those of us who are finishing, thank you very much